Okay, we are now almost 2 minutes past the hour, and I think folks have had a chance to join, so we're going to get started with this webinar. I'm Tim Erlin. I'm the VP of Product at Wallarm, and I am pleased to be joined by Mike Wilkes from the security agency, who is also the former Marvel CISO. Mike's done a lot of other things too, but those were the two that we picked to put on the slide at least. Before we get started, just a couple of housekeeping things. We are doing this webinar both on Zoom and on LinkedIn. So feel free to put questions in the chat on LinkedIn. And if you're on Zoom, you can put questions in the Q&A section there. And we'll do our best to answer questions either as we go or at the end if we have time for that. The recording will be on LinkedIn forever. So if you ever want to revisit it or share it, you can do it there. We're also happy to share the recording as well and the slides, so you'll have a chance to get a copy of those. And with that, Mike, first of all, thanks for joining us. I'm thrilled to have you here.
Thanks. I was just coming off mute and
there we go.
Rearranging my screen here. Yeah, it's great to talk with you again. We've done a couple of events, Tim, and you have a lot of fun information to share with people today.
Yeah.
Some insights as to how API security is failing us right now and what we can do to make it better. So looking forward to it.
Absolutely. So this is a webinar with sort of two purposes. One is to share the data from our API ThreatStats report, and the other is to get Mike to join us and comment on the contents and the implications of that report. So to get us started, I'll just talk a little bit about the report and some of the high-level details, and then we'll dive into the key findings, the three primary topics from that report. So if you're not familiar, API ThreatStats is a report that Wallarm puts together on a quarterly basis, and then we do an annual roll-up as well. So this is data from Q2 of this year. And it's an analysis based on a couple of different data points that we can gather. So first of all, the Wallarm platform itself detects attacks against APIs. We collect all of that data and analyze it. We also analyze public sources of data, so API-related security bulletins that are published, bug bounty reports, and API exploits that are published as well. So we think of that as kind of the data funnel for API ThreatStats. And we collect all that data, do a bunch of analysis, and produce some interesting conclusions and interesting statistics from all of that data. And again, it's a quarterly report, so we do this once a quarter and then an annual roll-up. So from Q2, I just want to share a couple of the high-level conclusions, high-level details that we produced, and we'll have a link at the end of the webinar for the full report if you want to dive into the details further. So I'll start with the analysis of API breaches that occurred in Q2. So I've got a list of the breaches here that we analyzed, so you can look at some of the details there. There were a total of 93.85 million users who were compromised across these breaches. So, that's a big number. It's always a big number when we talk about breaches. And you can also see a breakdown of how those users compromised were split across different industries. So the somewhat nebulous and large category of enterprise was at the top of the list there. SaaS came in second, then telco, aviation, and sort of when you get to aviation, it starts to get a little bit smaller in terms of numbers, or at least in terms of the significance there. Followed by media and consumer electronics as well. And we'll talk about some of the names here when we get into the analysis, but if you want the full analysis for each of these breaches, it's in the report. So there's lots of detail in there about what happened and why it's relevant as well. I'll also point out along the right-hand side, we've got sort of a root cause indicator. You can see that API leaks or some kind of leaked sensitive information was involved in the top section of breaches, the majority of them. I think if I add that up, it'll be majority. Broken access control, API abuse, and broken authentication there are along the bottom as well. So that's kind of the high level of the breach analysis, more details in the report. We also go through an analysis of the CVEs that were published that are related to API vulnerabilities. So obviously there are lots of CVEs. The first pass of our analysis is to narrow down to those that are API related. For what it's worth, the number that are API related keeps going up quarter over quarter. So the share of total CVEs published that are related to APIs is increasing. Here we pulled out total CVEs by category as well. So enterprise software, DevOps, enterprise hardware. The category for LLM and AI tools, tools and frameworks, that's a category that's been growing. So in our Q1 report, we pointed this out as a trend. We've seen that trend continue in Q2. We expect it will continue in Q3 as well. And then finally, development frameworks and cloud services. We've also got the vendors with the largest number of CVEs in Q2 here. Most of those you could probably recognize. The M here is Mintplex, which is an AI tool that's worth pointing out because it drives that AI subset of the numbers that are related to AI tools and frameworks. Also in that category of number 4, where we had a tie around 7 CVEs, you've got Grafana, Apache, and that other logo there is a company called Lunary, which is also an AI tool. So we've seen those AI tools driving, as I mentioned, an increase in the number of CVEs attributed to AI-related tools and frameworks. So that's the high level of the CVE analysis. Again, more details in the report, but gives you a sense of what we've collected there. And that brings us to sort of the 3 core findings. Anytime we do these reports, we want to share a lot of data, but we also want to pull out kind of the high level trends and findings that we want to talk about. So we're going to cover each of these 3 topics through the webinar. We're going to talk about how M&A has impacted API breaches, the AI topic, which I've already mentioned, and also how JWT or JOT, if you prefer, is impacting AI breaches and incidents as well. And
yeah,
so
life is too short to spend your time pronouncing that many syllables. So I prefer everyone to use JOT and just be efficient.
Well, and of course, if we really want to be painful, we'll say JWT tokens along the way.
Only if you're a member of the Department of Redundancy department.
All right. Let's jump ahead and talk about the M&A mayhem section here. So,
real quick,
yeah, please, Mike.
I like to provide context in case not everyone knows what an API is. And so let's unpack that real quick. Application programming interface, and why are APIs interesting? A quick check, this morning, getting ready for putting a few notes to share. Somewhere between 70 and 83% of all internet traffic is API traffic, and it's been this way for a while. So humans are a subset of transactions on the internet, and every app that you have has mobile apps, Slack, the operating system masquerading as an app. They all make API calls, right? That's how your Maps app on your phone knows that there's traffic, right? There's all this traffic and information being flurrying going around the internet, and it's not as well protected as the web application endpoints that we think of when we think about the internet. And so just to put that little piece of data out there, I think it was something like the increase in API is due to this modern digital implementations, and there are best practices around API security. But before we dive into some of those best practices and talk about some stories, happy to jump now back into the slide and talk about M&A mayhem.
Well, I appreciate you bringing us back to that point about sort of what are APIs and why are they relevant. The thing I think is important for me at least, to realize is that when I, as a human being, connect to a service, whether it's a web application or a mobile app, generally speaking, there's a flurry of API calls occurring behind my interaction, and those are driving not just integration with third parties, which are important, but also integration between microservices inside of that organization. And so it's not just that there are APIs exposed on the internet, but also internal, and just it's an exponential growth when you talk about the modern application stack.
Yeah, I think one of the stats that I read was from Imperva's report, and they talked about the average enterprise having something like 1.5 billion API calls, and a lot of those are actually wasted bandwidth due to lazy programmers that just push everything all the time, right, between the API and the mobile client or the web app. So there's a lot of room for exploits in all of that noisy, overloaded, verbose traffic.
Yeah, that's absolutely true. That's absolutely true. And so, we pulled out this finding around M&A, sort of as being a driving factor in the number of specifically in the number of breaches that occurred in uh, in the last quarter. A- And I think, Mike, you could talk about how what's the connection between M&A and APIs there? Why is that relevant?
Well, typically when there's a merger or an acquisition happening, you have a big fish eating a little fish, right? And that little fish offers something interesting to the big fish. That's why they bought them, right? But in smaller organizations, you usually have less discipline around documentation. And so you may have some legacy APIs that have been around at that acquired entity that nobody knows how they're working. It's not well documented. You can look in the code and try to figure it out. But in general, there's a lot of legacy technical debt floating around in the face of APIs. People don't turn them off and have a sort of normal software development lifecycle because it's painful often for them to figure out who's still using these old APIs and these old JOTs, right? And turning it off is like shooting yourself in the foot. No one wants to sign up for that task. And so basically, there's a lot of API gateways that come into effect where they do ETL, extraction, translation, and loading. Amazon has an API gateway, right? Wallarm has a lovely product to help you assess, inbound API traffic as well as outbound API traffic, right? If you put it through a proxy or through a firewall or other type of inline capability, you can inspect what's happening to some degree, and you can gain, at least an observability. But when the company is doing due diligence and they're looking at the application stack and the assets and the values of what they're acquiring, oftentimes they're acquiring a customer base or a set of talented engineers or a brand that they want to squeeze the life out of and kill. And so all of these have different risks to the acquiring organization. And unfortunately, the due diligence that was shared prior to acquisition often never shows up in the risk register of the merged entity after the fact, right? It's only gonna be 5 or 6 people that are a part of your M&A strategy that are doing the due diligence. And they may surface, oh yeah, we have this legacy API, no one knows how it runs. No one knows how to code it. The person that developed it left years ago. And so that's a risk, and it's highlighted as a risk, and maybe they get some deduction on the offer for the business they're buying because they're going to have to eventually pay the piper and pave over or uplift that API and patch it and upgrade it and improve it and harden it from security function point of view. But those folks forget sometimes to transfer that list of discovered, assets and risks into the new corporate risk register. And so everyone just blindly goes around, realizing that or not realizing that there's a risk here and the business implications and the impact of that API going down, whether it's through an attack or through um, you know, an expiration of another third-party package that was a part of it. All these dependencies are pretty hard to suss out unless you have a really good instinct for documentation and data flow diagrams, which almost no one has. So that's one of the things I like to champion and advocate for is documentation, documentation, documentation.
Everybody's favorite is documentation. It's a truly enjoyable job, right?
Yeah, well, it can get easier, with certain tools now. Amazon has something I think that they'll build as well that will sort of build you dynamic visualizations of what your application looks like. Because remember, there's what the architect designed, and then what the engineer built, and what you ended up buying, right? And so those are going to be 3 totally different data flows. And so I think it's important for people to at least tag these risks and surface them after the acquisition and put it on a list. Don't throw it into a Jira backlog. And again, M&As take a long time. Optum bought Change Health in October 2022. And Optum is owned by United Health Group. And this was not an API risk, but this was a asset management problem because no one had gotten around yet 2 years later to implementing good MFA on all of the internet facing endpoints that Change Health Group had. And that's how this ransomware attack got in. And that's how the risk of that acquisition even several years later, hadn't got around to standardizing the tooling and having one pane of glass for all of the exposed assets. And that's what causes delays in incident response and delays in understanding your attack posture and your risk. And so just think of APIs as being like underwater assets that people don't pay attention to, by default, let alone, is there good security to the right of slash? The API itself, and here I distinguish between like headers, in the front end to an API, and you can see that maybe it's running through a load balancer or something. But to the right of slash, you might actually have some other type of load balancer redirects that are sending something to a completely different application stack. And so when I worked at Security Scorecard, we used to score the FQDN, right? The fully qualified domain name. So just to take an example, api.appmeetwidgetcorporation.com. But there could be a totally different set of vulnerabilities to the right of slash login or slash v1 slash login versus slash v2, which might be implemented on Unix and another one implemented on Windows. So there's a lot of complexity to the right of slash, and people, again, don't necessarily have that well documented. It's not surfaced. And so I think it's important to really escalate the awareness and importance of doing APIs, having good inventory of them and ownership and monitoring. So that when bizarre things happen, like we saw with, what was that one? It was the Dell partner portal that got abused at like 5,000 requests per second or something, or per minute.
Yeah, it's listed here, somewhere on here. There it is. Yeah. 49 million records, and it was the partner portal that someone actually signed up as a partner and wasn't well validated, and then just went and scraped everything they could from the partner portal.
Yeah, there's no reason rate limiting and throttling shouldn't have been applied, to the partner connections to the API as well as the rest. So that's a good example of a legacy risk that didn't get surfaced, certainly got identified and exploited, and it's a good lesson learned for the rest of us.
To your point about documentation, I think it's valuable to keep in mind that you're right. Documentation doesn't necessarily mean writing a document. It can be automatically generated. And when you think about API discovery as a function, the point of API discovery is to create that inventory. That is essentially documentation task, but not just an inventory. It's important that that API discovery also do things like generate a spec for you, so that you can track changes against that API. So here's what it looked like today. Here's what's changed. And if you have the ability to generate a spec for what it should look like, what the developer expected it to look like, being able to take that next step from discovery to governance and compare the spec of what it should look like to what's actually in the environment gives you a really powerful diff to find things like exposed endpoints that shouldn't be there, or endpoints that should have been removed that haven't been, a zombie endpoint, for example. And those are all things that create risk in the environment.
Yeah, it's amazing the number of things that you can find. One of the tools I like to use when I analyze and do a risk assessment for a company is I will put in, their domain, their digital footprint, and get all the IP addresses and all of the FQDNs that pop out of tools like DNS Dumpster and things like that. So even legacy DNS entries aren't maybe active anymore. Again, right of slash might still be living behind some other FQDN. And it's like using the Wayback Machine, right? And going and looking at a website's, architecture and finding CGI bin print env.cgi or .pl, right? Living on an active path somewhere that no one turned off that still responds and prints out all the information about your environment. The Wayback URLs, there's like a Go script that you can use, and you just put in a couple of host names and it pulls down algorithmically through an API all of the URLs that the Wayback Machine has for that host name. So it's useful to look at sort of legacy attack surface because a lot of it has never been turned off.
Yeah. That's a good point. And so just to put a point on the M&A piece, because the reason that this came up as a particular trend for us is because of the number of breaches that were in business units that were acquired. So they're listed here. TestRail is a division of now, was acquired by Atlassian. HelloSign was acquired by Dropbox. Duo was acquired by Cisco, and Authy was acquired by Twilio. I think that's
sure.
Right.
And remember, Auth0 was acquired by Okta. And when it completed the acquisition, again, February, I think 2022, we all read the press release and all the business people are like, cool, we can start, changing our portfolio investment in Okta because they had this new capability from Auth0, but they never intended to merge the two. They kept them completely separate for many years.
Yeah.
And so when you had Okta breaches, you had the people at Auth0 saying, ha ha, rubbing their nose and saying, that wasn't us, And it's like, oh, come on, we're all in this together. But everyone in the market treats it as like a done deal as soon as the press release goes out saying the acquisition is completed. And guess what? It could be 5 years or more later when the actual integration on the back end starts to happen or finishes.
Yeah, that's absolutely true. And of course, if the situation is that they acquired a company for their cash flow, they're going to do less to interrupt that cash flow than they might if they acquired them, as you said, to acquire the engineering team, engineering talent, or to put them out of business. In which case, you can have separate business units, separate divisions that run very separately for a long period of time.
Yeah, that's true. It's like if you're in the housing market and you're trying to flip a house in 2 years, you really don't actually want to go into the basement with a radon detection tool and find out there's radon in the basement, or asbestos or lead paint or whatever. So a lot of times M&A does what I call skin deep, due diligence on security. And I think that pattern that ought to change. And I think the best way to change it actually would be to go into business schools and to teach the M&A business types about cyber risk, right? Because us technologists, we know about this stuff, but it's the people signing off on these deals that create systemic risk. And that's what we mean by, if I pay attention to my APIs and you pay attention to your APIs, then collectively our economy and our society is more resilient, right? But if we all just kind of agree that APIs are for geeks and not for businessmen and businesswomen, then I think we have a problem of perception.
Well, increasingly, I mean, we're going to see M&A continue, M&A activity continue, regardless. It may go up, it may go down, but it will continue. And the trends in technology all point to more APIs being present, more APIs being developed and used as, critical parts of the business. So I would expect that, those two trends will continue moving together, and we'll continue seeing APIs as, sources, causes for breaches of acquired entities. I don't see this trend reversing in any meaningful way.
Well, you're definitely a logical thinker, which means you're not the average thinker, Tim. But you would think that kind of logic would prevail and that kind of directionality would emerge. But there's periods of neglect, right? If you think about what happened with Twitter, Elon Musk taught the world that you can fire 80% of the staff and still keep your business running. I think that's a really bad lesson learned for CEOs everywhere. There's plenty of talent that could have stopped bad things from happening and worse things from happening, to the Twitter revenue and trust and all of that.
Yeah.
And the same kind of thing is bound to happen with some of these fish, acquisitions.
Certainly true.
Fish eating little fish.
Yeah, certainly true. Certainly true. All right, well, let's move on to the second primary trend or major trend from the report. And this is really about the as we put, AI API exploit explosion, which is a mess of alliteration to say 5 times fast. But the point here is that we're seeing, obviously an increase in the use of AI and AI tools, specifically generative AI, and that they're really backed by APIs. A lot of these integrations are API driven. And for lots of different reasons that we could talk about, there's an upward trend in the number of vulnerabilities and the number of exploits related to these AI tools, which we see in the data.
Yeah, there's also a data loss prevention element from the InfoSec perspective. And here we have to appeal to our partnership with legal. You've heard of no code, low code, or low code, no code, citizen development.
Well, yeah, but let's touch on that for a second, as you did with me explaining what APIs are. Let's talk about what low code and no code really means.
Well, from an InfoSec point of view, it means the security officers and team did not review the integration, and the engineers had nothing to do with it. So this is basically a citizen development and empowerment thing for people to copy and paste a token in Slack or in Salesforce or some other tool, and just copy and paste it with a third party that's going to AI enrich, their understanding of their pipeline, intention to renew, churn rates, things like that. And it's a real risk. It's a real nightmare from us, having that offloaded, right? It adds speed and agility and empowers sales and marketing people and revenue ops, as they call it, to do their work. But it becomes a problem if you don't audit it and review it. I remember doing an audit of a Salesforce org several years ago, And there were like 447 integrations. I'm like, they can't all be live, right? And so clearly threat actors are going to find some of these, buy them up, or even contribute to the open source package that goes into the functioning of these tools, and architect and inject what we call, or I like to call, a sub-zero day, meaning they're creating the backdoor and just waiting for it to show up in a package. 2018, Sonatype published an article about one called Event Stream, which is part of NPM. And they knew that this package Event Stream is used in a lot of Bitcoin wallets. And they knew that Bitcoin, crypto kind of technology companies weren't terribly adept or deep on their security. So they waited for this Event Stream package to make it into these wallets. And they had a special obfuscated bit of code that allowed them to siphon off untold millions of dollars. So imagine, taking this to the API hype cycle that we're in right now. There's no data flow diagrams being updated when people just copy and paste, a Slack token or a API token into an integration. There's no data classification happening, and of course, these kinds of things do need to be decommed when they're not used anymore. Otherwise, you have this dangling, sort of like you said, zombie API risk hanging out there. And a lot of them don't need to be running anymore. But it's, again, considered a little bit too burdensome to have a robust, check even once a year, or, you'd like to think it could happen quarterly. But in the rush to market, features and functionality always win out over non-functional requirements like security and availability. So I think you'll see a lot of interesting root cause analysis from some interesting exploits and breaches and supply chain risks, that are happening through AI APIs. And folks are just, like I said, willy-nilly sharing data without really an understanding of the impact and the potential data loss of intellectual property, PII, regulatory fines. So this kind of stuff, you just need to cut it out, knock it out, stop doing this dangerous, promiscuous API stuff.
There's an interesting, you talked a little bit about this idea of citizen developers. We as an industry have spent a lot of time around, the secure software development lifecycle, educating developers how to develop securely, what things to worry about, how to eliminate vulnerabilities or prevent them from occurring. But that same type of education, we struggle with getting people, average users, not to click on malicious emails, but we're now potentially empowering them to, effectively, do this low code, no code development. Do we need a it's a long acronym, Citizen Software Developer Secure Software Development Lifecycle Initiative?
Well, I think that if we wanted to start somewhere digestible, right, rather than trying to eat the elephant in one sitting of all this risk that we're describing, would be to simply make sure we pay attention to the final elements of the life cycle, which is decom. No one ever decoms anything. That is our historical pathology, right, as software teams. Everyone wants to book the new win for the new feature. I like to try to gamify it. I usually make like a wiki page or a Confluence page and call it the graveyard. And everyone that gets to contribute a decom, gets to have like a pizza party or something, right? And you want to gamify and reward people for turning off stuff that's at the end of its life cycle, and to identify things that need to be turned off. I remember an outage for a company that I was advising about. They're using LaunchDarkly, and they had an out-of-date, no longer supported end-of-life SDK on their client to do this A/B testing that you use LaunchDarkly seeds for. And eventually, they shut it off, and that caused a huge cascade failure for the entire, application and the APIs behind it. And so really there's supply chain risk here. There's dependencies that you may not be aware of. I mean, how many people didn't even know that they had CrowdStrike, going to disrupt their, July 19th Friday travel plans? There's a concentration risk that happens with some of these vendors as well. And I like to make sure we call it the CrowdStrike Windows outage, because guess what? Linux and Mac OS kept running just fine. So there's a little bit of blame to be shared with Microsoft and having a fragile blue screen of death from a single file that doesn't parse, it's malformed, shutting down 8.5 million computers and giving a lot of IT support teams a really bad day and weekend to lay hands on those machines to recover them. So I think we need to take some of the higher level lessons learned from these outages and disruptions, whether they're malicious or not, and figure out, well, do we want to have OS level you know, diversity? Or do everyone want to go out and buy like 50%, of a brand new EDR and mitigate the risk of a CrowdStrike repeat of this problem, by having some other tool in place?
Yeah.
There's a huge, soft cost to doing that for training and for integration of policies, having two different tools in place. So I'd rather have the lesson learned be, you know what, a little bit more OS diversity would be a good thing in critical production environments. So if you can run some of your systems on Linux, I highly recommend that you architect that in, because it's the same app, you can have the same endpoint, but it would be, exposed to different frailties, and allow you to be more fault tolerant, essentially.
That's really interesting. There is somewhere, the possibility of scoring, providing some kind of a resilience score based on the diversity of technology or the tech stack in place. That's just an interesting concept to consider.
Yeah, one quick way to
yeah.
capture that, if you don't mind, I like to call it the digital potato famine. When I do these sort of year-end, predictions, I've pulled this one out of my pocket for the last couple of years. Some QA failure, not on the part of CrowdStrike, but on the part of a threat actor, right? Because they're dealing with return on investment and total cost of delivering payloads and exploit code, and they fail to QA the device, the malware, adequately, and it ends up bricking a whole bunch of devices because of this sort of homogenous, everyone on iOS is always on the latest version, or at least N-1. And that I predict this will happen eventually, right? And what we saw with CrowdStrike was a very similar type of effect, but not through
Not through an attacker.
the negligence of a threat actor. And so everyone knows about the potato famine in Ireland, and one blight wiped out the whole crop, and people were starving and dying, and it was horrible. And so I think the same kind of thing needs to be thought of in terms of resilience through diversity in our application stack, in our canary, release cycles, staggered releases of updates. And so I think CrowdStrike's going to be releasing probably a new product that you have to pay extra for now to get canary releases of 0-day patches and vulnerabilities. So they'll turn this sort of black eye into an additional revenue stream, I think.
Oh, it would make an interesting tabletop exercise to, you don't even have to specify the threat. You just say it impacts all of, this particular application, this particular software stack, whatever, this operating system, and then have to figure out what that, how you get your organization back up and running with the loss of all of your, all your Windows boxes, or all of your Kubernetes installations, or, yeah.
We do have a LinkedIn question. You want me to read it?
Yeah, let's see.
Can you throw some light on what specific AI-driven threats should organizations be most vigilant about when securing their APIs?
Yeah.
So my first pass on that would be to say, make sure you have the ability to do version control. Because if your API that's feeding your chatbot turns into a racist, sexist Nazi overnight, you want to be able to roll back pretty quickly. And a lot of times people are just talking to an API, and the API, the model on the back end could be updated, it could be corrupted, it could be accidentally switched over to a development instance or something. There's my dumb. Sorry. But anyway, that's my first pass on one of it, and that's more about the integrity of APIs, right? If the trio, the triumvirate of InfoSec is CIA, confidentiality, integrity, and availability, we're looking at availability risks, through some of these things, and integrity risks, but not necessarily the encryption algorithms, right? The confidentiality.
So I'll pitch there the OWASP top 10 for LLMs actually is a reasonable starting point. If you want to think about what kinds of threats impact AI specifically, that's a good starting point. And if you want to have a fun exercise, take the OWASP top 10 for LLMs and compare it to the OWASP top 10 for APIs. The two are very similar. In fact, we had a speaker at one of our API summits who argued that they're essentially the same, with the exception of, I think, two of the items. That the flaws that you need to look for are very similar. So it's a great exercise to look at that top 10 list as a way to understand what those threats might look like.
Yeah, they did a little bit of copy paste and replace. Another quick question came in. What API cybersecurity tool do you find interesting that's launched recently? Well, when I was working at a healthcare startup, we were working on AI for like the last 10 years. ChatGPT is just a blip, in the perception of AI and the history of large language models and other types of machine learning. One of the things I made sure we set up a proxy between us and any of the APIs that we wanted to talk to make sure that there wasn't any PII or PHI going into those requests. And there's different ways to sort of enforce that. You certainly don't want somebody just opening up a standalone web browser executable for Chrome or Firefox or something, and bypassing all of your web-based controls, right? Because you can write a package into your Chrome and into your managed web browser that says, hey, if you're going to chat, gpt.openai.com, we want you to go through this proxy so that we can at least log what you typed, what came back. And that gives you the first tenet of security, which is observability. But there were some great tools that I saw people start to develop. There must be plenty more now, which would be like Guard, GPT, and things like that. And so people have basically taken the same idea and said, well, at the very least, you need to be able to know what's happening, on these calls. And of course, Wallarm's product and the community edition, as well as commercial, are both excellent examples of how to do this, in mass, right? Not just for one target URL or one target API. Even if you get the sign off, from Microsoft, say, hey, we're not going to train our model. We're going to give you an isolated, instance that's frozen in time, and you can use it and trust that we're not going to, surface any of your business sensitive or other types of information, through errand copy paste. But remember, all of this stuff existed prior to ChatGPT as a risk, and it was just people just copying and pasting random shit that came back from, Stack Overflow, right, and other forums. People will do dumb copy paste stuff. So I think one of the best mitigations for the risk of AI enthusiasm, if I can call it that, is to just simply have some good security awareness training, get your legal team to agree on some principles, publish those principles, have a 20-minute all hands meeting talking about it, and getting everyone to ostensibly commit to not doing, stupid user tricks, right? With AI in your exuberance to figure out, hey, the Samsung gave us the first mistakes, right? They're like, hey, we're going to copy and paste our 5-year strategic plan into this chat window so it can summarize it, meeting notes for us, right? And then suddenly everyone can extract, Samsung's 5-year strategic plan.
Right. Yeah. Okay, I know there are a couple of questions there that we haven't answered yet, but I'm going to move us forward and come back to those questions as we get a little further into the deck here. So moving on from AI in this case, we're going to talk about JOT and its role in API security or API security incidents, vulnerabilities in this case that occurred in Q2. So Mike, can we just do a little bit of an explanation of what JSON Web Tokens or JOT is, or its role in APIs?
Sure. Just think of it as the next thing that's being overloaded after passwords were overloaded. Right?
That's a good way to put it.
Passwords were overloaded on a military base, so you could pass through the gate. And you would say the word that allowed you to pass through the gate. Now, of course, passwords have the job of doing auth N and auth Z and all of this other type of stuff. So JOTs are just a way to do that, in a more, I guess, scripted machine-to-machine fashion, and under the hood for the human interactions. But let's just go to the worst of all possible worlds scenario here. So let's say that you inherited some long-lived JOTs, right? They're going to be around till 2032, and you don't have any infrastructure as code in place to retire them. And on top of that, you're not entirely confident that you know actually how many are in use, right? Because you have poor logging coverage. So you can't even create an accurate census, let alone sample of all the JOTs that are in use. And that's something that I've had to do in a couple of organizations. We're like, look, identity and access management is not just about service accounts and human, secrets. It's also about all of these other machine secrets that are being used under the hood, like you said, on the back end or on internet-facing elements. So I think JOTs are terribly insecure and overloaded in what they're being asked to do. The analogy I have was when the first US passports came out back in like 2006 that had NFC capabilities, right, for near field communication and to transmit the data. All of the vendors that submitted bids to take over this contract leading up to 2006, producing the e-passport, none of them could agree on a way to do a bootstrap encryption handshake. So guess what? All the passports were simply broadcasting your name, date of birth, and your passport number, and issue and expiration date in clear text, because they couldn't agree on a standard to bootstrap that initial security. JOTs have the same kind of problem. People use them, they're functional. It's easy to copy and paste a little bit of code and get things up and running. But no one's ever done a threat model. No one's ever done a security review of that. And people feel sheepish about it, so they don't ask the InfoSec team to come in, and do it during the design phase, where it should.
Yeah, or functionally they don't have a good alternative to propose if the the JOT implementation is rejected. There's the challenge. JOTs do solve a problem, or at least from a design standpoint, they're intended to solve a problem in terms of supporting authentication without sharing secrets. But what we saw in the data, at least, is there are a host of issues, some of which are operational and some of which are implementation. Right? If you take a JOT and you say don't share this, and then it gets shared, that's an operational problem.
Or
and
they
that's what
put it
occurred
into
with
the
Beam,
mobile app, right?
Yeah.
They hard code it into the mobile app. Someone then decompiles it, reverse engineers it. That's a huge mistake, because you can't expect people to not do that with your mobile app. So you really do need to have just-in-time credentialing for APIs and this type of technology, just for the point of control and visibility. So put it into a shared secrets, storage solution for humans and for machines. And when developers build a Slack channel and they just keep pasting all of the interesting JOTs into it because everyone's dev builds break every now and then, that's a sign of a pathology, right, on secrets management. So if you go and you search, through the messages in the channels on your Slack or elsewhere, or email even, or even code, of course, check your repos, look for JWTs and inventory them, find owners, classify the type of data that's being transmitted, make sure that any PII or PHI is being encrypted prior to it being encapsulated in these web tokens. That's certainly the beginnings of cutting some of the cruft and the mistake out of their implementation. There's one bullet down there that I'd like to mention real quick as well. Create a few canary tokens. Create a few tokens that you don't actually use. Put them out there with your regular credential stores and Git repos and all that. And as soon as that JOT gets used, write a little bit of code that sets off a silent alarm saying, hey, guess what? This is not a real JOT. It's functional, but we put it there, as like flypaper to catch, curious people that might be insider threats from nation states or bored teenagers or disgruntled employees. So I think it's an interesting area for us to inject some deception technology and to use, like I said, canary tokens and deception tokens and have them light up whenever used.
Yeah, I think that's a good suggestion. Yeah. Appreciate that. Okay, cool. So I think we covered the three main topics. I want to offer a couple of sort of concluding thoughts, and then we'll get to answering any questions that we have left at the end. So we've talked about a couple of different topics here, and one of the realizations that I came to in preparing for this particular session is that while there are a whole bunch of different topics or disciplines around cybersecurity, information security that people often feel are distinct, that APIs tend to connect them all. And this is increasingly true. So you might be talking about supply chain security, which came up in this session as well, but you're also talking about API security because your vendors are connected through APIs. We might be talking about AI, which we talked about in this session, but behind that is really an API security need. The same is true for SaaS security, data security, cloud security. So increasingly, as we move forward, we're finding that that APIs and the need for API security kind of underpin a lot of the disparate or previously disparate security topics. And I think that's an interesting observation from the data that we have today. And then the next thing I wanted to talk about was sort of getting back to basics, because anytime we talk about a newer security discipline like API security, there's a tendency to really focus in on the technical details, on what makes it different on this specific protocol or this specific attack. But the reality is that in a lot of cases, you can kind of go back to the basics. So if you feel like it's overwhelming to understand what you're supposed to do around securing APIs, I picked the Center for Internet Security, CIS, because I just like their 18 critical controls as a good starting point. They're not the only set that you can use, but it's a good starting point. So CIS, if you're not familiar, has these 18 critical controls. There's a lot of information on them and a lot of detail that you can get into. CIS is a nonprofit, so it's freely available. Their goal is to improve security. And I took these critical controls and just for fun, I mapped them to what I thought you could do with API security. So just as an example, the first critical control is about inventorying hardware, essentially, enterprise assets. It's not really applicable to APIs necessarily, but the second control is about the inventory of your software assets. That's absolutely relevant for APIs. You need to inventory all your APIs, including their business functions and owners, just like you would inventory other software assets that you have. And you can go through the list. You could talk about the control for continuous vulnerability management. Well, yeah, you have to find and prioritize vulnerabilities in your APIs. So while the vulnerabilities themselves may be novel or interesting, the basic control that you need to apply is consistent. It hasn't really changed. It's still vulnerability management, or it's still security awareness and skills training. It's still managing your service providers. It's still penetration testing. Those core controls remain largely consistent, even though the topic has shifted and the technology may have shifted.
Yeah, I totally agree. This is an important message for everyone to be able to echo. Don't get distracted by the shiny objects. If you saw the movie Up, this is like squirrel, right? 0 day. The basics are not fun in most cases. They're not sexy, definitely. But the top, controls from CIS version 8, it used to be top 20, then it became 18, then they decided to not call it top X. They just said top controls because they wanted to be able to change it without having to rebrand and rewrite everything. But I use this all the time. I have done dozens of assessments for organizations because what's really cool about these is there's about 153 controls under these 18 domains. And they're all grouped under IG 1, 2, or 3, which is implementation group 1, 2, or 3. So it actually gives you a sequence to go after them. And the IG 1 controls are table stakes for any organization that has a digital service of any flavor or kind, even if it's just a Facebook page, right? Or I guess I'm dating myself there, a LinkedIn page or a TikTok, or an Instagram, identity. So even if you have a tiny footprint with like just 2 IP addresses, and it's a website and it's probably WordPress or Drupal or something, you can still walk through these controls and find some interesting areas to invest in mitigating the risk. Because these are the ones that, cloud security, version 8 was revised to include a lot of modern things. A lot of the frameworks don't stay up to date. I remember I was looking at some questions from when we started our FedRAMP moderate package, or other types of audits that were happening at Security Scorecard. And one of the controls was like, do you encrypt your offsite tape backups? And I was like, man, there's a hassle of assumptions built in there, because I can't say no, and I can't say yes, because I don't use LTO2, LTO3. I mean, you have to go to a museum to get those kind of drives, right? So frameworks age, poorly, like milk. And so I'm glad to say that CIS stays on top of it. This is a great framework. Of course, NIST CSF version 2 came out in February.
Yep.
That's a really good starter framework for people to use as well.
It is.
But walking through this is table stakes, and that's how you can bring some calmness into the room when it's a frenzied discussion about, oh my God, we have to introduce APIs and AIs, and we have to do all this stuff, and we don't know how to do it well. And it's like, well, if you do the basics of InfoSec well, then guess what? Your AI implementations and all of your sexy, API integrations and low code, no code will also be protected by doing these basics: access controls, malware defense, backup, tabletop exercises, security awareness, things like that. So I would totally echo and support this point, which is, this is not Olympic diving. You do not get extra points for the difficulty of your attempted control, and risk mitigation. Go for the basics. That's how you win. That's how you protect your organization and your evening's rest.
Yeah, absolutely. And you could do this same exercise with the NIST CSF as well, actually, if you wanted to. Again, it's about what I love about it is that ability when approaching a new problem space to bring along essentially a fairly simple approach and say, great, I understand we have a new technology, we have a new a new problem space. Are we keeping, are we keeping a clear inventory, and do we have control of the assets involved? Are we protecting the data involved? It's straightforward. And you can apply that to API security as I've mapped it here. And of course, because this is a Wallarm webinar and we are a vendor, I have also gone through and mapped done the same mapping or similar mapping of the CIS controls to Wallarm's capabilities, which is a slightly longer list and a little bit harder to read. So we can summarize it a little bit here and call this slide, how Wallarm can help maybe. But we've got the ability to perform API discovery in a number of ways, including comparing to your specifications. We've got the ability to find a number of issues with vulnerabilities or API leaks or misconfigurations, authentication issues, and then finally, and perhaps most interestingly, the ability to simply detect and block attacks that are coming across to your APIs, and those are the key capabilities there. So
Yeah, that's
yeah,
great.
go ahead, Mike.
I like to reference WAF when we talk about API. And if you've ever implemented a WAF or web application firewall, which is like usually layer 7, the interesting thing is that if you configure it to be really, I don't know, robust, you're going to have a lot of false positives. You're going to have shooting yourself in the foot. You're going to have a developer that adds a few extra parameters to an API call, and the WAF or the web site is going to break. And if you back off of the WAF and you make it not so tightly integrated with your code and your endpoints and your URLs and the parameters, then it's essentially a sieve. And so I think API firewalls and the same kind of technique needs to be an inline capability that can do certain stuff heuristically and behavioral based. Saying this doesn't seem right at all. Why are you passing like 8,000 characters to the login URL when it really should just be username, and password or something, right?
Mm-hmm.
And so I think there's some very basic controls that can be, observed and codified, into the Wallarm products, and to not have that burden of having 1,000 different endpoints tightly coupled to the development release, which causes a lot of like I said, shooting yourself in the foot, self-inflicted wounds. So having an inline capability to observe and then intervene if needed is a really powerful mitigation for API risk.
Yeah, absolutely, I agree. So while I go through these last two slides, if you have any last questions, feel free to add them now, and we'll see if we can get to them all. So
one of the ones that was in there was how do we detect design drift between runtime and design specs? And I think you mentioned that, right? You can analyze the spec if it's like self-documenting. I think tools like MuleSoft and things like that do that. And runtime deltas are where a lot of creative developers say, oh, I need to get this data, and I don't want to have to go through the normal channel. So I'm going to open up a port 80 listener, and I'm going to talk to production. I'm going to pull the data in and circumvent all of the security controls. So it's important to realize that as designed and as built are always going to be, have a delta. So what are some ways to detect that? Well, you need automation to be able to scan, your code base, which is ostensibly what was designed and meant to be implemented. But what actually runs in runtime can be tweaked with, unfortunately, and can be modified and behave in ways that are novel and unexpected. That's what we call systemic risk, right, for complex systems. And really, the world of APIs, 80% of all internet traffic is a systemic risk right now. There's such dependencies. One tiny little blip here can cause a massive outage there. And I don't have to hyperbolize this. I can just refer to CrowdStrike Windows outage. Everyone knows what I mean now.
And keep in mind that when you're talking about drift, just looking at the way this question was asked, you're implying drift from something. And so understanding what that from object is important. Is it drift from what you expect or what should be in that environment, in which case you're looking for a specification that comes out of development, says, here's what we intended to build and deploy? Or are you talking about drift from a previous state, in which case you need to be able to produce a record of that previous state in order to create that comparison? And they're two different things.
Mm-hmm. Yeah, I think configuration drift is one sort of adjective that's applied. And configuration management tools, infrastructure as code is the way to try to get a handle on that. If you have a cluster of 8 nodes, they should be running identically. But if you have these sort of snowflake approach, or pets instead of cattle approach to your infrastructure, then people are going to go in there and tweak and fix things live in situ, right? Interactively on a production, Kubernetes node or something. And then you're going to have drift, right? Between what should be identical instances. And of course, just drift over time. There can be novel behaviors that emerge when something's been online for 1,000 days, right? So I always like to think, and you've heard this, I'm sure, before, the DevOps manifesto is that we need to treat servers and infrastructure and compute as cattle and not pets.
Yeah.
So we need to slaughter them regularly and deploy from scratch in order to be fault tolerant, resilient, and to know that what's in the repo is what's actually been pushed out and is running on the production and non-production environments.
Yes. Yeah. Yeah. It's true. I see one more, one more question in here. For people developing their own web app, what are the most common security issues that should be addressed before releasing in beta mode? Would OWASP top 10 be sufficient? It's a reasonable question. I think
OWASP top 10 goes really far, actually.
Yeah. And it's important to point out that OWASP, as I mentioned before, OWASP produces top 10 lists for different technologies. So there's an OWASP top 10 for web applications. There's an OWASP top 10 for APIs. There's one for LLMs.
And there's one for mobile.
And there's one for mobile. There are more, yeah. And so
and the other
depending
thing
on what you're building.
The other thing is just make sure that if you're developing your own app, stand on the shoulders of giants, right? Don't reinvent the wheel. If you need to have an embedded video player in your app, right? Don't go write your own. Someone's already written a really good one. Go find an actively supported wide community open source package that does an embedded video player, kind of capability. When I worked at Marvel, I was on the open source committee for Disney, and we used to review I think it was every week almost, maybe it was every month, open source use requests, right? And there'd be people saying, oh, I want to use this 0.2 version of this thing written in Ruby Rails. And I'm like, why? No, it's a risk to the business, to have one person in their Yama or their Llama, right, supporting this code base that you're trying to introduce into like the ESPN app or, the Parks and Resorts app or something, right, or mobile apps. And so I really think it's useful to be lazy, copy and paste, imitation is the most sincere form of flattery. Use active, healthy, vibrant open source packages and communities, and then never copy and paste some big old project because you want to bootstrap your project, because you're bringing over 80% cruft, as in code that could be vulnerable and be exploitable, and you're bringing it over because you didn't want to so I'm kind of saying two things, use other people's stuff, but don't wholesale copy it, because that's just a bad way to reproduce vulnerabilities.
You know what you're saying, Mike? You're saying you should do all of those integrations through APIs instead of pulling over all of their code.
That would be nice, but a lot of people haven't implemented or instrumented APIs on the legacy side. And so I've seen a lot of really errant copy paste when people say, oh, this does most of what I need, I'm just going to use it as my baseline. No, you really ought to strip out a lot of that cruft, because it's going to make your vulnerability scans and your software composition analysis light up, saying, like, why is log4j in here? You're not even using it. But some malicious code inject could turn it on and make it an exfiltration point, right? So you really need to have data minimization. You need to have code, documentation and comments. You need to have commits, on the repo as to why you're doing stuff for the people that come after you, right? You're not going to be at this company that you're working at now for 10, 20 years, probably. So document as a courtesy, to those that come after you, and you'll appreciate it when you show up in a new company somewhere and it's got a good documentation instinct and culture. And it may not be fresh, but at least it's not, completely ignorable, stale.
Thank you, Mike. So just to conclude, I don't see any more questions in the chat. I've got up the slide for our next webinar. So if you enjoyed this webinar, come to the next one. We'll talk about a new product launch, actually, and how you can secure your external API attack surface. If you didn't enjoy this webinar, come to the next one anyway. Give us another chance. Why not? But I want to thank you, Mike, for participating and joining us. I think it was as always, an interesting conversation, hopefully interesting for everyone else as well. And
Thanks.
hopefully we'll see you next time.
Yeah, I appreciate the chance to talk with you about this and get people to read the ThreatStats report.
Cheers. Thanks, everyone.